Okay, welcome back. Welcome back again, once again. Today we're going to look at the second half of the lesson on picture this. So now we're away from the whole subject of schematic diagrams, but there's similar info about schematic diagrams. So Gordon West, the author of your manual, put some of the information about electronics into this section. So we're going to continue looking about electronics. We're going to see what a tuned circuit is. We're going to look at rosin core solder and soldering, and we're going to look at this unit called decibels. But don't worry about that now. We're going to jump into this. There is a lot of information in this section, so I am going to have to move a little quickly. So if you get confused with any of the points here, just refer back to the Gordon West manual. Definitely read the chapter after this video lecture, and that should help clear up any questions you may have. And of course, you may also email me. Anyways, let's get started. The first thing we're going to look at is a tuned circuit, also known as a simple resonant circuit. So what is a tuned circuit? A tuned circuit consists of a capacitor plus an inductor. Do you remember what these are? So the capacitor stores energy in an electric field. The inductor stores energy in a magnetic field. Now somehow, when you connect a capacitor and an inductor, you get a tuned circuit. And what does that mean? Well, so a tuned circuit, the capacitor and inductor can sort of tune the circuit to operate at a certain frequency. So this is actually how they tune ham radios to a certain frequency. They use a tuned circuit. If you want to tune your radio to 14 megahertz to transmit on 14 megahertz, they'll have a tuned circuit that tunes everything to 14 megahertz. You don't need to know all the technical aspects of what exactly it means for a circuit to have a certain frequency and all the details about that. This is really all you need to know for the exam. And this is how they often tune radios to a certain frequency, using this capacitor plus inductor combination. Alright, so there's a few things on this test which aren't too hard, and the first thing is a meter. So what is a meter? You probably already know what a meter is. Specifically, the test is asking about analog meters, like the ones that have a little needle like this. So the meters, they display things like signal strength and do it on a numeric scale. Think of the meter in your car, like the speedometer. It's a little needle, right? And it tells you sort of how fast you're going based on the numbers and which number the needle is pointing to. That's a meter. And in ham radio, we don't use these meters to measure things like speed of your car, but we do use them to measure things like signal strength. Okay, so now with meters out of the way, let's move on quickly to relays. Relays are pretty easy. A relay is basically just a switch, like an ordinary switch we learned about, like a light switch maybe, but a smaller switch usually controlled by an electromagnet. So an electromagnet is basically a magnet that's controlled by electricity. So in other words, the electricity makes that electromagnet magnetic. If there is electricity, then the electromagnet acts as a magnet. If there's no electricity, then it ceases to be a magnet and nothing's attracted to it. Metal's not attracted to it anymore. So the electromagnet is used to control the switch, and that's called a relay. Alright, now let's look at a regulator. What is a regulator? A regulator is also simple. A regulator's job is to regulate the amount of voltage that comes out of a power supply. So, in ham radio, you're going to have a power supply that supplies power to your radio from the commercial power in your house. And the regulator, it basically regulates the amount of voltage coming in from the power supply. It controls that voltage. It regulates the voltage. Alright, so now let's look at a transformer. A transformer's job is to change the high volt AC. It changes high volt AC to low volt AC. So do you remember what AC is? That stands for alternating current. And it's the sort of power that's used in your home, in the wiring in your home. And also it's the power going along the power lines outside your house. That's AC as well. But there is actually a little difference here. The AC going through your power lines, that's very high voltage. It's a very high voltage AC. In fact, it's so high voltage, it's too high voltage for your house. So what we often have is we have transformers. If you look at the top of your electrics pole, you'll notice a little box usually, maybe a cylindrical box. That's a transformer. It changes the high volt AC to low volt AC so that the low volt AC can enter your home. High volt on power lines, lower volt in your home. So a transformer is used to transform the electricity from one voltage to the other. Alright, the next thing we're going to learn about is an integrated circuit. And again, this concept is not too hard to understand, at least compared to some of the other things in ham radio. But an integrated circuit, it combines and integrates several small components or semiconductors into one giant component. So in other words, an integrated circuit is basically a circuit with everything integrated into it. So instead of plugging all sorts of little components into a circuit, like all sorts of capacitors and resistors, and it gets very messy, you just have to plug in one integrated circuit that already has everything. It can make things easier. So for example, say that you need there's part of your giant circuit needs to contain a mini circuit that controls something which involves these capacitors and resistors. You might put these capacitors and resistors in this small component into this integrated circuit. This circuit has everything integrated, and then now instead of many little components, you just have one component that you need to plug into the circuit. And obviously, this can make things easier when you're trying to work with electronics. All right, now we're going to get to something that's so important that I wrote it on the board, or my sister wrote it on the board. We're going to look at decibels, decibel questions. You may or may not have heard of decibels. If you haven't heard of decibels, that's okay. Decibels is basically a unit for loudness. It tells you how loud something is. You know, we have meters and centimeters that tell us how long something is, distance. You might have noticed we never have a measure for loudness. Actually, we do. This is decibels. Decibels is a measure for how loud something is. And obviously, this is important because we're dealing with radio, and that implies we're dealing with sound. So there's a few tricks you need to know for the test. Every time the output power of a sound is doubled, the decibel level actually goes up by 3, and vice versa. So in other words, you know, say that you're transmitting power to a speaker. You're using a certain amount of electric power to power that speaker, right? If you double the amount of power going to that speaker, the decibels are kind of strange. They're what we call logarithmic. If you've taken certain math courses, you may or may not know what that means, but they're not linear, they're logarithmic. And you don't, you don't need to know exactly what that means. All you do need to know is that when the power is doubled, the decibel level isn't doubled. Like if the decibel level starts at 3, it doesn't suddenly go up to 6. Or if that's a bad example, if the decibel level starts at 4, it doesn't go up to 8. Every time the power is doubled, the decibel goes up to 3. So if the decibel level was originally 4 and you double the power, it'll go up to 7. And vice versa. So when power is doubled, decibels goes up by 3. This is the symbol for decibels, a little small d and a capital B. When the power is halved, the decibel goes down 3. So if you go from, say, 1,000 watts to 500 watts, you lose 3 decibels. Now, a 10 times increase, when power is multiplied by 10, the decibel also goes up by 10. So if you go from 20 watts to 200 watts, you add 10 more decibels. So decibels are kind of weird, as you can tell, but as long as you remember these 3 rules, which you can write on your notebook if you want, you'll be okay as far as the technician class exam is concerned. So now let's move on to solder, which for some reason is written up here. So we're going to look at some solder. What exactly is solder? So solder is how we glue things together in a circuit board. So you think about it, you know, you have a component like a capacitor. How do you get that to fit in the circuit board and be connected with the rest of the circuit? This is solder. So, you know, we have electrodes. In a capacitor, there's 2 wires sticking out of the capacitor that plug into the circuit board. So in the circuit board, there are 2 little holes in the circuit board where we put those wires in. So then we drop the capacitor, we put the wires through the holes, and then it's in the holes, but it's not really a tight fit. So the capacitor still isn't connected to the circuit. So this is when we solder everything together. What we do is we melt some solder. Solder is basically just a piece, it looks like a thin piece of metal wire. And we get what we call a soldering iron, which is very, very hot. And when we touch the soldering iron to the solder, it melts the solder, and the solder sort of liquefies and falls apart. And what we can do is with a soldering iron and a solder, we can melt the solder around the hole and around the little wire sticking in the hole from the capacitor or resistor or whatever. So think of this as the circuit board. This is the electrode from the capacitor. This goes in the hole, and then the solder, we melt it, and it goes all around this extra space in here, and it connects the wire to the circuit, make sure it's connected to the circuit. And that's how we connect things. So this is called solder, and we use a soldering iron in order to melt the solder. So the test will ask you some questions about solder, or actually maybe just one. It'll ask you what type of solder is best to use, and it'll list a few choices. So for some reason, I'm not going to go exactly into why this is, but rosin core solder up here, rosin core solder is the best type of solder to use when you're dealing with electronics. And although I don't have a technical explanation for you, I do have a trick. Just remember that rosin core rocks. It rocks. It's a great solder. You know, it rocks. Rosin core rocks. R-C, rosin core. Rosin core. Rosin core rocks. R-C, rosin core. That'll help you remember. So sometimes when you're soldering something onto a circuit board, sometimes the solder makes a bad connection and it doesn't connect the component to the circuit very well. So this is known as a cold solder. That's what we call it. So a cold solder, if you look at it with your eye, it'll look like a grainy or dull surface. And if this happens, if you see this, that means it's a cold solder, and this is a poor soldering job. You didn't do a good job. The circuit isn't going to work well. The component isn't really connected to the circuit board very well. It's not going to work, and you probably need to do it again. So anyway, that's what a cold solder is. So finally, some of the last things we're going to look at is meters, or our meters. So especially multimeters. So multimeters are cool in that instead of just measuring one thing, like only voltage or only resistance, they're multimeters. They have multiple meters built in. They can measure voltage and resistance and maybe even some other things, like current. So one thing that you need to be careful of when you're using multimeters, make sure that your multimeter is set to the right setting. For example, if you're measuring voltage with your multimeter, make sure your multimeter is set to voltage, not to resistance. So this is actually very important. In fact, I fried one of my multimeters because I set it on resistance, but then I plugged it into a cord into the wall. And it turns out that resistance meters, they're not built to handle high voltages. So what happened is I plugged this sort of into something directly plugged into the wall, and it was set to resistance, whereas it should have been set to voltage. And sparks actually lit up inside my multimeter, and the multimeter actually lit up inside because there were so many sparks in the multimeter, and it started smelling like smoke, and I fried my multimeter. So the resistance circuit is not built to handle high voltage, only the voltage circuit can. So make sure that you're setting it to the right setting. See, I should have set my multimeter to voltage because that's what I was supposed to be measuring, but I set it to resistance. Make sure your multimeter is set to what you actually want to measure. That's very important. So an ohm meter is, it's not a multimeter. An ohm meter only measures one thing. Obviously it measures resistance. Remember, ohm is the unit for resistance. So there's another tip I have for you that's going to be on the test about an ohm meter. Make sure that the circuit you're testing is off when you're measuring the resistance with your ohm meter. Because you don't need the circuit to be on. The ohm meter will supply its own power through the circuit in order to measure the resistance. If you turn the circuit on and electricity is flowing through the circuit and you plug the ohm meter in, you're going to destroy your ohm meter. The ohm meter is going to get fried. So that's obviously not a good thing. There's one more thing the test will also expect you to know about ohm meters. Now, sometimes you might plug an ohm meter into the circuit, and at first you might not see any resistance at all. And then as you're not doing anything, it's just sitting there, all of a sudden, suddenly there is resistance. And suddenly, you see increasing resistance on the ohm meter. Even though you're not touching anything, you're not doing anything, but for some reason, the resistance is just gradually going up in some mysterious way. Is it magic? No, what you probably have is you have a large capacitor probably in your circuit. So what happens is the capacitor starts up with no charge in it, right? So you see no resistance. But as the capacitor charges up from the power from your ohm meter and gathers energy, it charges up and it increases the resistance in the circuit. And this explains this phenomenon of the ohm meter reading just gradually. The resistance just increases over time. All right, that's the last thing you need to know on this section. So again, there's a lot of material here, and some of it can be confusing. So I really encourage you to study even more in the Gordon West Manual. And after you feel like you've got the material down, you can take the quiz and use it for review. And after that, I will see you in the next lesson, which is antennas. We're going to learn about antennas, which is a pretty obvious thing you need to know about in ham radio. So it's going to be a lot of fun, very interesting lesson. So I will see you then.